All right, guys, welcome to our Unit 6 Quiz 2 study guide. We're being asked to find roots. I'll go through the even problems. You guys can do the odds if you want extra practice, okay? Answer key is provided for the odds as usual. So let's go ahead and find all of our roots. We're going to do this by factoring. Step 1 is to look for a GCF. So there is an x that we can take out. Step 2 is to factor that using the box method because there are 3 terms. And when there's 3 terms, we use the box method. You know that you've done things correctly if these two add up to make the middle. All right, and we want to keep factoring. This guy here is a difference of squares. The square root of x squared is x, and the square root of 1 is 1, so we get x plus 1 and x minus 1. This last one is not a difference of squares because there's an addition instead of subtraction. And what we do now is we just set each piece equal to 0 and solve. So x equals 0, x minus 1 equals 0, x plus 1 equals 0, and x squared plus 4 equals 0. This one's done. For this one, I just need to add 1, and then I'm done. This one we need to subtract. And this last guy here, we got 2 steps to do there. We're going to subtract first. Then we're going to take a square root. The negative comes out as an I. And the square root of 4 is 2. So it's 2i. And there's our roots. We have 2 imaginary roots and 3 real roots. 1, 2, 3 real roots, and 2 imaginary roots, a positive and a negative 2i. So this polynomial would touch the x-axis 3 times, once for each real root. Let's take a look at another one here. Step 1 is to factor again. This time there's no GCF, so we'll jump right into the box method. This one has 4 terms, so when you do the box method with 4 terms, there's less guesswork that has to go on. You just put the numbers, all the 4 numbers in the box, and then take out whatever they have in common. All right. You always want to check to make sure that what you've got on the outside there actually works to make the inside, and it does. But anyway, we have x to the 4th minus 16, and then x squared minus 5. Now this guy here is a difference of squares, but this one, we're not going to treat that like a difference of squares because 5 doesn't have a nice square root. But x to the 4th minus 16 can be factored using a difference of squares. Square root of x to the 4th is x squared. Square root of 16 is 4. You make one a plus, you make one a minus. So we already said this one's done. This is not a difference of squares either, but we have another difference of squares here. So we're going to break that up. The square root of x squared is x. Square root of 4 is 2. One's a plus, one's a minus. And then we bring the other factors along that are prime. And now we're ready to set everything equal to 0 and solve. -2 2. We solved this same problem on the last one, so we're going to get the same answer, but in case you didn't watch that part, I'll work it out here. Notice it's an I because I'm taking the square root of a negative. Don't forget your plus and minus. Anytime you take a square root, you get a plus and a minus. The square root of 4 is 2, so our final answer will be plus and minus 2i. Last one here. Oops. Take a square root on both sides. Don't forget a plus and a minus. 5 doesn't have a nice square root, so we'll leave it like that. So this thing has 4 real roots. 1, 2, 3, 4. There's a positive and a negative square root of 5. These ones here are imaginary roots, but there are 4 real roots, which means this polynomial touches the x-axis 4 times. All right, let's go ahead and take a look at number 6 here. Says state the possible rational roots. So for that, we take the last number and we take the first number, and we're going to make a list of all their possible factors. So 1 is easy. The only thing that goes into 1 is 1. But 64 has quite a few numbers that divide into 64. 1, 2, 4, 8. I don't think 12 does. 16 does. And 32 does. And of course 64 itself. Right? And the way we do this is we take the factors of the last number and put them over the first number. So it could be plus and minus 1 over 1, plus and minus 2 over 1, plus and minus 4 over 1, plus and minus 8 over 1, plus and minus 16 over 1, plus and minus 32 over 1, plus and minus 64 over 1. Now technically we don't need the over 1s, right? Anytime something's over 1, it's just the number itself. Sometimes you'll have 2 numbers here. So you would have to write that many fractions again, this time putting these over the second number. Don't forget to reduce them if possible. But like I said, I'm just going to go ahead and get rid of the over 1s. It's not necessary for mine, because anytime you have 1 in the denominator, it doesn't really do anything, so we'll like that. So these are the possible roots. There are 2, 4, 6, 8, 10, 12, 14 possible roots. There's 14 possible places where this polynomial may be touching the x-axis. We're not sure if they're actual roots, but they are possible roots. And that brings us to our next question. How do you know if they're actually roots or not? Well, the way you know they're actually roots is by plugging them in and seeing if they equal 0. So what you're going to do is you're going to plug these numbers in to this equation. And you're going to see if you get 0. If you get 0, then it's a root. If you don't get 0, then it's not a root. So let's plug that into our calculator. If you want to try to do it by hand, you can. I'm not going to do that, though. I'm going to use a calculator. So just give me a minute here as I work it out. And I get 160. That's not 0. Therefore, this is not a root. So I need to test that for the other 3 problems also. And actually, I was wrong. This one does come out to be 0. So that one actually is a root. But here's the rest of them also. So when I plugged in -4, that didn't give me 0. And when I plugged in 20, that didn't give me 0. But these 2 did. So those are my 2 roots. And on the test, make sure you check all 4 of them, because it may be one or more answers, and you're going to bubble in all the answers that are roots for these. Okay. So moving along to number 10 here. We're going to factor this polynomial, but right now we can't use our regular factoring methods to get the answer because it's too long. We've only learned how to factor polynomials that have 2, 3, or 4 terms, but this one has 6 terms in it. So what we're going to do is we're going to scale it down a little bit by using the root that they gave us. So here's one of the roots that they've given us. The first thing we do is we're going to divide that root into this polynomial, scale it down. Just so you remember, if that's a root, then this would be the factor that goes with that root. Okay. Now, I'm going to divide this polynomial by that factor. Okay. Now you don't have to show this step if you don't want to. You could jump right to the next step, but just want you to be aware that we are going to divide to break down the polynomial into something smaller. So we put all the coefficients of the polynomial here, and we put the opposite of this number, or in other words, the root as it was originally given to us here, and then we do our synthetic division. Now your remainder should be 0 for these problems, because if you ever divide a polynomial by its factor, it should go in there evenly. It shouldn't have a remainder. So this thing is now simplified into x to the 4th plus x squared minus 20. That's all. We don't need these ones, so that's what's left as a result. And then we have this factor here, x plus 3. Now we're going to continue factoring this, and as you guys can see, we would use the box method to finish it up. So with these problems, you start off with a polynomial that's too big for our traditional factoring methods. We use long division to scale it down a little bit, and then after that, we get it down to the size that we would want, and just use our regular factoring methods. So now I've got x squared minus 4, x squared plus 5, and x plus 3. Finally, this guy here, we could do a difference of squares on it. That's supposed to be a 3 there. All right. And all done factoring. So step 1, synthetic division. Step 2, factor like normal. All right. A lot of work. I know these are busy. Let's move on to our last bit here. Describing the end behavior of a polynomial. All right. So if I want to describe the end behavior, the limit as x approaches infinity of the function. We need to do that for positive infinity, and we need to do that for negative infinity. Now, as we talked about, all you really need to do is take the first term and plug in infinity to that. Or in the second case, negative infinity. Now when you square infinity, you get infinity, and there's still a negative in the front, so it's negative infinity. For this guy, when you square negative infinity, you get positive infinity, but there's still the negative in the front, so it's also negative infinity. And what that means is that for this graph, on the right side of my graph, it goes down. On the right, it goes down. And on the left, it goes down. I don't know what this polynomial looks like, but I do know that whatever this stuff does in the middle, the left-hand side and the right-hand side have to look like that. Okay, let's take a look at one more. So I want to find my end behavior on the right side, and I want to find my end behavior on the left side. The one that determines the end behavior is the first term. Here we're plugging in a positive infinity. Here we're plugging in a negative infinity. On the top, if you cube infinity, it stays infinity, and we still have the negative in the front. On the bottom, if you cube negative infinity, you get negative infinity. But we still have another negative in the front, so this one actually becomes a positive infinity because the double negatives cancel. And what this means is that on the right side of my graph, we're going down. Right is the positive here, down is negative here. So on the right side of my graph, we're going down. But on the left side of my graph, we're going up because it's positive. So once again, I don't know what this graph looks like, but I do know what the right and the left-hand side should look like. Okay? And I think that'll do it. So hopefully that was helpful. We'll see you guys for your quiz tomorrow.